Okay, so today we're going to review density, which is a concept that we've talked about a few times in the course, but also something you've learned about way probably back in middle school. And then we're going to talk about or apply it to explain molar volume, the concept of molar volume. So if you think back to what density is, my favorite analogy for density is this, an NHL puck versus a sponge puck. So a real hockey puck versus a sponge hockey puck. They're both the same size, the same shape, they have the same volume, but one is much heavier than the other, and that's because of density. Density is simply the amount of stuff you have in a certain amount of space. So when we're talking about a sponge puck versus a regular puck, there's a lot less matter in the same volume in the sponge puck than there is in the hockey puck, the regular puck. So the density is just the mass of your stuff in a certain amount of volume. So your units could be grams per liter, grams per mil, grams per centimeter cube, pounds per square, not square inch, pounds per cubic inch. It could be any sort of mass in a certain amount of volume. Now, it's a physical property of all substances, so certain things have certain densities, and you can see that with this little demonstration. You may have seen something like this before, where you can separate out all these different liquids, solids, and things because they have different densities. This is why certain things will float on top of other things. So, same volumes of different gases will have different densities, but the same number of particles because of their molar masses. So if we're talking about a box of helium and a box of carbon dioxide, if they contain the exact same amount of particles, they'll be in the same volume, same pressure, same everything, but one will be heavier than the other because its particles are heavier. So if you look in this box of helium, because the helium particles, if you actually count up the number of blue circles and the amount of 3 red circles, the blue circles, there's the same number as the red circles, it's just that the blue circles are lighter, so the density is less. You have the same amount of stuff, but the stuff is lighter. So a little bit of density review. So you can think of density like a ratio, just like molar mass. The density of aluminum is 2.7 grams per centimeter cubed. So you could say, well, you have 2.7 grams for 1 centimeter cubed. Or if you have 1 centimeter cubed, it's the same as 2.7 grams. So we can set up density as a ratio. Anytime you have something per something, it is a ratio. So here's some examples of calculations involving density. If you have 10 mils of water and it weighs 10 grams, what's the density? Well, in grade whatever, you probably learned that density is mass over volume. But we just know it's how much mass is in a certain amount of volume. I don't need to memorize the equation. I just want to make the units look like that. So I'm going to take my 10 grams and divide by my 10 mils, and 10 divided by 10 is 1, and the units that remain is grams per mil, or grams divided by mils. So there's your density of water, and that is the density of water. It is 1 gram per milliliter. So if you have 1 milliliter of water, it should weigh exactly 1 gram. Now, diamonds have a density of 3.51 grams per centimeter cubed. So what's the mass of a 1 cubic centimeter diamond? So we can actually figure out how much this diamond would weigh. So if you have 1 centimeter cubed, and we want to find the mass, I'm going to times by the ratio that gets rid of centimeters cubed and leaves me with grams. So we know that 3.51 grams, oops, I put an extra grams in there, takes 1 centimeter cubed worth of space. So 1 centimeter cubed times 3.51 grams, so it's 3.51 grams of diamond. So if you have a 1 cubic centimeter diamond, it will weigh 3.5 grams. Copper has a density of 8.92 grams per centimeter cubed. What would be the volume occupied by 18 grams of copper? So if you have 18 grams of copper, we want to find out how much volume or how much space that takes up. We know that 1 centimeter cubed is the same, or would weigh 8.92 grams. So if we have 18 grams of this stuff, it would be just over double the amount of volume. So we divide this out, I get 2.02 centimeters cubed. If you look, grams cancel. Now let's think about if this makes sense. It takes almost 9 grams to have 1 centimeter cubed, so if you have 18 grams, that's twice as many grams, so twice as many centimeters cubed. It's kind of the same idea. So that brings us to something called molar volume, and density is one way to prove this molar volume thing, and we'll get to that in a minute. Molar volume is the volume occupied by 1 mole of gas. Now remember that pressure and temperature will have a huge effect on gases, so this will always be at standard pressure and standard temperature. We've talked about standard pressure is 101 kilopascals or 760 mmHgs or 1 atm, but standard temperature is actually 0 degrees Celsius. And it just so happens that at that temperature and at that pressure, if you have 1 mole of gas, it will occupy 22.4 liters worth of space. So you have 22 liters for 1 mole, or 1 mole is 22.4 liters. Doesn't matter which type of gas we're talking about. Every time you have 22.4 liters of a gas at standard temperature and standard pressure, you will have 1 mole of gas in that container. At room temperature, it's going to be a little bit more because room temperature is warmer, so the volume would spread out a little bit more, so it would be a little bit bigger. But with chemists, in science, we always have a standard, and 0 degrees Celsius is our standard temperature that we work with. So if we know the volume occupied, we can calculate the number of moles present. So if we have, let's say, for example, 67.2 liters of oxygen gas, and we want to find the moles of oxygen we take 67.2 liters, and we're going to get rid of liters. So I'm going to put liters on the bottom and moles on the top. So we know from that molar ratio that if you have 1 mole, it takes up 22.4 liters. Well, 67.2 divided by 22.4 is 3 moles. So if you have that many liters, you actually would have 3 moles of gas. If we flip the way around, go the other way around, let's say we have 3 moles of gas. Let's find out how many liters that would be. So it's the same idea, 3.0 moles, and we want to get to liters. So moles on the bottom, liters on the top. And we know that it's 22.4 liters for every 1 mole. 3 times 22.4 is, again, we're back to 67.2 liters. Moles cancel. So if we have 1 liter of nitrogen gas, so 1 liter of N2, and we want to find out how much that would weigh, well, the first thing we do is we know our ratio between liters and moles. So let's find out what that is in moles first, and then we have a ratio for mass in moles. So we're going to go from liters to moles to mass. So it looks something like this. Cancel liters, put moles on the top. So we know 1 mole is 22.4 liters. So that's going to be 0.045 moles. And now, since it's nitrogen gas, that's 28 grams per mole. So we're going to cancel out the moles and get grams. Notice I can't jump right from liters to moles, or liters to grams. I have to go through moles. And that's why moles is such an important thing, is it allows us to convert from one unit to the next. So we have our moles. Now we're going to go to our grams. It's 28 grams for every 1 mole, and I get 1.26 grams of nitrogen. So if you have a liter of nitrogen gas, again, remember gases are spread far apart, you actually have now 1.26 grams. Now, you can also prove molar volume. So if we wanted to, we could figure out, like we can find the density of a gas just by weighing a certain volume of gas and then evacuating that gas and seeing what the difference is. So let's say we found out the density of hydrogen gas, and this has been determined, is 0.089999. Okay, so now using that, we can actually calculate this molar volume, this 22.4 number. Let's just assume you have 1 liter of this stuff. Okay, and we want to find this molar volume. That's liters per mole. Molar mass is grams per mole, molar volume is liters per mole. So let's say we have a liter of this stuff. So if we have 1 liter, and we know the density is 0.089999, so we're going to get rid of liters and find grams. So 0.08999 grams for 1 liter. So this ends up being 0.08999 grams. Now you probably see why I chose 1 liter, because it's easy math. So now, if we have that many grams and we want to find out how many moles that would be, let's cancel out grams. We know from the periodic table that 1 mole of hydrogen gas is 2.02 grams, because the hydrogen gas is H2. So when I divide this out, I get 0.0445 moles of H2. Now, the question wants me to find liters per mole. Well, we just found out how many moles it takes to have 1 liter. So if we wanted the units to look like this, I'm going to take my 1 liter, I'm going to divide by the number of moles it would have, 0.445 moles. And if you actually look, liters divided by moles is liters per mole, and 1 liter divided by 0.0445 ends up being 22.4 liters per mole. And this is where that number can be derived from.